Hey guys, so looking at some of the things in Chapter 6, Section 1 that we haven't got to yet, I wanted to first remind us what we've already talked about, looking at the sum of all these cylinders, pi r squared, times the height, but we want those number of cylinders to go to infinity, gives us this nice integral. When we talk about the washers, we're just subtracting off that inner cylinder, and then we have again a very similar formula: pi times the larger radius squared minus the smaller radius squared. So that's giving us the volume of a washer as we rotate it around the axis. So what I want to look at now is what happens if we are going not on the x-axis but the y-axis. So here's a problem which talks about, we're going around the y-axis versus the x-axis. We still have a whole bunch of cylinders, but now they're going around the y-axis. So our function isn't in terms of x, it's in terms of y. And so that's why we're getting this different formula, right? So we're making the function in terms of y versus in terms of x. So that's why it has our inverse function here. Done the exact same way, you're going to see a pi times a radius squared. But again, our radius is on the y-axis. So done very similarly, when we're computing these, it's just that we have to think we're going vertically, not horizontally. Or I guess our radiuses are going horizontally, not vertically. Here's an example that I had in the book where basically we just had a cylinder up into this point, and then we had washers. And so that's what they did. They broke it up into two different pieces. It's a pi r squared up until 1, but from 1 to this e to the 2/3, we have the larger radius squared minus the smaller radius squared. So that's how we integrate this particular one that has us looking at the volume when we're kind of looking at almost like a piecewise function. We're going to split it up because it's something from 0 to 1, and then it's something else from 1 to e to the 2/3. Another idea that they talk about at the end of section 1 is what happens if I'm not going around the x-axis or right around the y-axis. So if I'm looking at a piece like this, here's my function, like the output's at 2 and then goes up. And so when you're thinking about this, what is the height of this thing? Again, and I am rotating around this horizontal axis of 1, not the x-axis, but a y equals 1, so this other horizontal axis. So the height of this function is not, the height of the function is 2, but the height of the radius would be 2 minus this distance of 1. So you're going to see when they do their big radius squared, they're doing it minus 1 because it's the output, the height, minus 1 squared is going to be what your radius is. The other value of 1, again, what we have here is a cylinder with the radius of 1. So we still end up with a pi r squared, pi times 1 squared. And then the height will be taken care of with our bounds, our change in x. So if you get these functions that are rotated around a different axis, we just have to make sure that we subtract that off so we'll know what the actual radius is. Again, if we look from here, the radius is 1. So it's not at 2. We would have to subtract off what that height value is, that y equals 1. So this should kind of wrap up the things that we had for section 1 to still do. On Wednesday, the plan is to talk about any last questions from section 1, and then start looking at section 2, which is doing volumes by shells.